This is the Enzmann Echolance, a vessel that was designed by Dr. Robert Enzmann decades ago, utilizing technology that we are very familiar with today to send human beings across the vast gulf of interstellar space. I covered this particular ship and its designer about 2.5 years ago, but in that time, my subscriber base has more than doubled. Over 100,000 new subscribers have joined the Angry Astronaut since I came out with that video, and I think it's high time to talk about interstellar travel with people who are big fans of 3I Atlas, the third interstellar object to visit our solar system. Would it be possible for an alien civilization to cross the vast gulf of interstellar space and pay us a visit in a reasonable amount of time? And more importantly, would it be possible for human beings to go visit them in an equally reasonable period of time? Considering the enormous distance that just a single light year represents, this seems almost impossible. Voyager 1 and 2, two of the fastest spacecraft that humans ever designed, are going to take tens of thousands of years just to travel 4 light years. That being the case, how could it be possible for even extremely advanced civilizations to travel much faster than that? Could they travel close to the speed of light? And even so, how could you possibly traverse the distance between stars hundreds or even thousands of light years away from one another, even at that colossal speed? It seems like an insurmountable challenge. Impossible even for civilizations many thousands of years more advanced than humanity. But actually, Dr. Enzmann came up with a way, utilizing technology that we can envision today, technology that we are actually using today, to traverse the distance between the stars, even distant stars, in a very reasonable amount of time, traveling as many as 20 light years in a single month. How is this possible? We're gonna find out right now. Good afternoon, spaceflight enthusiasts, and welcome to another Angry Bulletin. Today we're going to discuss a topic that I visited a couple of years ago, the work of Dr. Enzmann. He was a man dedicated to the pursuit of interstellar spaceflight, an individual who put out some pretty controversial work in his long career, but he was a big advocate for alternative methods of reaching not only the planets, but of course the stars as well. He advocated for a rapid progression to this type of technology, arguing that the resources that humans could acquire in other star systems would be unique and different and incredibly valuable, and with the kind of technology that he talked about, returnable to humanity, that is to say, a journey to, say, Alpha Centauri or perhaps even Barnard stars, some of the stars nearby, and then bringing it back, all of that being doable in a couple of decades, therefore making a return on investment, this kind of expedition, pretty enormous. He also advocated for other strange things, such as older people embarking on a one-way interstellar trip as sort of a retirement, their last hurrah, making their way out into the stars in a vehicle that would take them to a variety of different interstellar locations before they finally died. But how is all of this possible? I mean, all of us know that the distance even to the closest star is just utterly colossal. We're talking over 4 light years, about 4.2 light years from here to Proxima Centauri, and it's one planet in the Goldilocks zone of its star, Proxima b, and even with the fastest propulsion systems that we can imagine with today's technology, it would take centuries to reach this destination. Perhaps if we use some sort of light beam propulsion, that is to say, using extremely powerful lasers to push a light sail to perhaps 10% of the speed of light. You're still talking about almost half a century to reach this destination. So was Dr. Enzmann just out of his mind? Is there really no way with today's technology, or at least our understanding of the technology required to get to the stars, just beyond our reach, and all of this is just science fiction? Well, not necessarily. First, we need to talk about the speed of light. Many people discuss the possibility that breaking the light barrier, so to speak, might actually be possible. Not by traveling faster than the speed of light. We know pretty much for a fact that that cannot be done. Einstein's equations and theories of relativity, and especially the relationship of matter to energy, make it impossible for matter to travel faster than the speed of light. Relationship of E equals mc squared, his most famous equation, proves that. Energy and matter have a relationship whereby traveling faster than the speed of light simply violates the known laws of the universe. But perhaps there might be some other way, say through a warp drive or utilizing wormholes, hyperspace, these sorts of theoretical constructs used to not necessarily go faster than the speed of light, but instead fold space, make the distance between you and your destination shorter by warping space, or by traveling into a different reality or a different universe briefly and then returning to it. All of these things have been explored pretty thoroughly, and a warp drive is at least theoretically possible, although the energy requirements are utterly colossal. And not only that, it requires certain types of things like negative matter that we don't even know if that exists or not. So there are some problems with warp drive which may never be overcome. And really, when it comes right down to it, to drift into my UFO enthusiast persona for a moment, if traveling faster than the speed of light, warp drives, hyperspace, whatever you want to talk about, if any of that was really possible, then certainly many extraterrestrial civilizations would have mastered that by now, and we should be up to our armpits in aliens, certainly by now. Some sort of interstellar civilization should have made the journey to our planet and announced their presence. Certainly not all of them want to be coy and sneaky about the whole thing. There would have to be one firebrand out there who would insist on making contact, and yet that has never happened. In my opinion, that simply means that traveling between the stars is a pretty difficult thing to do, and really only possible for stars that are relatively close to your star, to the point of origin. But all that being said, even if traveling faster than the speed of light is beyond the realm of possibility, then why did I put this title on the thumbnail? Why am I talking about the possibility of traveling 10, 20, maybe even more light years every single month? How could that possibly be done? Well, it's all about the relationship of matter and the speed of light. Even though traveling faster than the speed of light is impossible, traveling extremely close to the speed of light, 99.999% of the speed of light, is just fine. It does require a lot of energy to get you there, especially that last percentage point from 99 to 99.999% of the speed of light. The amount of energy required increases exponentially. The mass of the object traveling that fast, its inertial mass, actually increases the closer it gets to the speed of light, requiring more and more and more energy until you get to the point that all the energy in the universe can't accelerate it any faster than it is traveling. That tiny fraction of a percentage point from 99 point whatever percent of the speed of light and 100% of the speed of light. But still, you can go that fast. Interestingly enough, funny things start to happen when you travel that close to the speed of light. And there was a particular point, a particular scenario that was put forward by the legendary Carl Sagan almost half a century ago now, and I'm going to go ahead and relate that story to you now. It's a story of two young boys in Italy, one of whom has a magic scooter capable of traveling at 99.999 and so on percent of the speed of light, and his little brother, whom he asks to wait for him as he goes off on his fateful journey. It's Paolo's first day with his magic scooter. He can't wait to travel at 99.999% of the speed of light. But unfortunately, he's stuck this day with his little brother Vincenzo. He doesn't want to carry his little brother with him on the back of the scooter. That seems like a very risky thing to do, even though Vincenzo definitely would like to do that and expresses his discontent with the situation in the way that many little boys do, but Paolo asks him to be patient. He leaves him on a park bench and says that he will be right back. He's only going to take a ride of perhaps 5 or 10 minutes, and he'll be back to pick up Vincenzo, and then perhaps they can ride together. And off Paolo goes, accelerating rapidly to 99.999% of the speed of light. And as he does so, strange things start to happen. From the perspective of passers-by, Paolo appears blue shifted from the front as light is compressed ahead of him, and red shifted from the back as light is stretched out behind him by his enormous velocity. Although to Paolo, everything seems normal, at least with him, but not to the world around him. Paolo sees the entire universe that he can perceive anyway compressed into a single halo of light ahead of him. Everything that he has just passed is still ahead of him, but on the outer fringes of the halo, whereas everything that is coming towards him is at the center of the halo. But there is no light behind him, no light to the left or right. Everything in the universe is crushed into this single halo, at least from his perspective. It is a strange experience, to say the least, but in spite of how exciting it is, Paolo keeps his word and returns in a mere 10 minutes. When he does return, he finds something shocking and very sad awaiting him. Everybody he's ever known has grown up, moved away, and died. And there's Vincenzo, still patiently waiting. Now, all this may seem completely ridiculous. Why does traveling this fast produce these kinds of results? It is the strangest thing in our natural world. Why would traveling faster cause you to age more slowly, cause time to pass more slowly for you? Well, as a matter of fact, this absolutely does happen. It even happens for astronauts orbiting our planet. If you have, for example, one brother on the International Space Station orbiting the Earth for a year, and then his twin brother here on Earth also not orbiting the Earth, not traveling as fast as the International Space Station does while orbiting our planet, the brother in the ISS actually ages about 1 second less than the brother here on Earth. It's actually been experimented with, and far more significantly, particles that are accelerated to near light speed, relativistic speeds very close to the speed of light, also age far more slowly, far more slowly. And it gets to the point to where these particles that physicists have experimented with that should only exist for a few milliseconds actually survive for several seconds, perhaps even as long as a minute, while they're traveling at that kind of velocity. Now, they should have deteriorated. Their half-life should have led them to have simply gone out of existence, but they don't. They continue to survive while traveling at that kind of velocity, and that's simply because their rate of decay is slowed tremendously because time for them is traveling that much more slowly. And so that is what makes it possible for travelers on board Enzmann's ship, the Echolance, the Enzmann Echolance, to traverse these enormous distances within a human lifetime. Not just within a human lifetime, within just a few months' time. The Echolance is a ship that utilizes these kinds of particles, these particles that travel very close to the speed of light, to provide enormous amounts of thrust, unbelievable amounts of thrust that utterly dwarf the capabilities of rockets, nuclear rockets, or any other type of propulsion that we can conceive of. And it's the sort of technology that we've actually possessed since the 1950s and 1960s. So let's have a look at the Enzmann Echolance. This is Dr. Enzmann's concept of a far future space station that launches Enzmann Echolance ships, several at a time. His mission concept for this spacecraft involves at least 2 of them traveling side by side in case any of them run into technical problems or runs into problems with personnel, those sorts of things. You could actually transfer from one ship to the other without any difficulties as long as both vessels were traveling at approximately the same speed. Now, some of you may be scoffing at that, thinking of how dangerous it would be to leave the protection of your ship at 99% of the speed of light, but I'm going to get to that. First of all, how do you get to this kind of velocity in the first place? Well, a non-stop application of 1g thrust, in other words, just matching the gravitational pull of our planet, will drive an object to very close to the speed of light in a year's time. That's all the time it takes if you are delivering that much thrust continuously to reach 99.999, etc. % of the speed of light. And the closer you get to the speed of light, as we saw with Paolo and Vincenzo, the slower time passes. This phenomena, by the way, is known as time dilation. And as you get closer to the speed of light and time passes more slowly, from the perspective of the passengers on board, you are traversing enormous distances in no time at all. As I said in the thumbnail, as much as 20 light years in a single month's time. Perhaps even more than that if you can get closer to the speed of light. But how does the Echolance actually accomplish this? Well, by using those very same relativistic particles that I talked about earlier in the video, the ones that decay at a slower rate because they are traveling so fast, meaning that the Echolance makes use of an entire battery of particle accelerators, which shoots hydrogen atoms, ionized hydrogen atoms that is, out of the engine nozzles at relativistic speeds. This means that the particles are traveling incredibly fast, providing a lot of thrust, but in addition to that, since the particles are traveling so close to the speed of light, they also weigh a lot more than they did when they were at rest, providing even more thrust. As a matter of fact, a few grams of this kind of material being accelerated to these kinds of speeds provides the same amount of force as a 100 kilogram weight traveling at 30 kilometers per second. This means that instead of having to consume millions and millions of tons of fuel just to get a 1,000-ton spacecraft up to 99% of the speed of light, it takes roughly 1 ton worth of material for every ton of spacecraft being accelerated to this velocity, a ratio that is simply impossible with any other type of propulsion system. It, however, does require a very powerful reactor in order to generate the necessary energy to drive the particles out the back of the ship at this kind of velocity, but we're not talking about super advanced reactors here like antimatter or fusion. A conventional fission nuclear power plant, likes of which we've been making since the 1950s, could definitely produce enough energy to get the job done. So the Echolance is essentially a bundle of particle accelerators with a series of hydrogen fuel tanks, frozen hydrogen that is, or hydrogen snow. The hydrogen is then heated up and ionized and placed into an electromagnetic field and accelerated to relativistic speeds. The ship is large enough to house up to 3,000 people, and as you can see, it also contains mining pods, corridors, luxury decks, airlocks, engineering decks, hydroponics decks, habitat areas, of course, and recreation areas, even shops, dining, school, archives, pretty much an entire city in space, traveling at relativistic speeds. And what you just saw there were nuclear-powered aircraft designed to transfer crew from the ship down to the destination planet. So really a very ambitious spacecraft, but according to Dr. Enzmann anyway, something that could be built for as little as $10 billion or so. Not nearly as expensive as one might think, and easily within the capabilities of most modern nations. But how fast do you really need to be going before the effects of time dilation becomes apparent to the passengers on board? Well, it's 66% of the speed of light. For every 1.34 years that passes in the outside world, 1 year passes for the passengers on board the ship. So not that big of an effect, but definitely noticeable. Once you get up to 90% of the speed of light, though, things really start to change. For every 1 year that passes on board ship, 2.29 years passes in the outside world, meaning that you're actually traveling 229% of the speed of light, roughly, by your perspective. In other words, as time passes on board, it seems like you're traveling at 229% of the speed of light. It's actually a little slower than that, but you get what I mean. Let's get up to 95% of the speed of light. Now, every year that passes on board the ship means that 3.2 years is passing in the outside world, meaning that you're traveling at about 300% of the speed of light. Now we get up to 99% of the speed of light, and 7 years passes for every year passing on the ship. In other words, about 700% of the speed of light. Again, from your perspective, but that's all that matters, because in the time that you're aging, your ship is traversing enormous distances in the outside universe. Now let's go to 99.9% of the speed of light. 22.36 years are passing in the outside world, meaning that you're traveling at 2,230% of the speed of light, meaning that you're traveling almost 2 light years per month. And as the thrust continues, the speed continues to build by tiny, tiny fractions, but those tiny fractions make a huge difference to your apparent speed. At 99.999% of the speed of light, 223 years pass in the outside universe for every year that passes on board ship, meaning that you're traveling at 22,300% of the speed of light, or almost 1 light year per day. And there is almost no limit to this. At 99.9999999% of the speed of light, that's 8 nines after the 99 percentile mark, you can traverse the entire diameter of the galaxy in 1 year and 3 months. Now, of course, this doesn't help the people you've left behind, nor does it mean you would have anything meaningful to return to after making a journey like this, but nevertheless, if we're talking about much shorter distances, traveling at this kind of velocity makes interstellar travel very, very feasible, not only within a human lifetime, but perhaps in only a few months. And when you consider that there are 83 known star systems within 20 light years of Earth, the concept of an interstellar empire or an interstellar civilization with the sun at the center becomes a real possibility and not just science fiction. But how does this apply to 3i Atlas? I know a lot of you have been waiting for this. How could this possibly apply to what we're seeing flying through the solar system right now? Well, first we have to talk about one of the greatest threats to a spacecraft traveling at this kind of velocity. Even the tiniest particles at this kind of speed colliding with your ship would be utterly devastating. Just Single particles would be the equivalent of cosmic rays, incredibly high energy radiation bombarding your ship and everybody inside it. Now, theoretically, those particles could be deflected away by powerful electromagnetic fields, similar to the electromagnetic fields that you use to power the particle accelerators. But as far as slightly larger particles are concerned, say tiny motes of dust in interstellar space, the impact of these tiny bits of dust on your spacecraft would be cataclysmic. As I mentioned before, something weighing just a few grams traveling at this velocity would have the same effect as a projectile weighing 100 kilograms traveling at 100 kilometers per second. That being the case, then, we need to have some way of getting these tiny bits of dust out of the way of the spacecraft. Now, fortunately, there is very, very little dust in interstellar space. Here in interplanetary space, most grains of interplanetary dust weigh anywhere from 10 to the negative 16th power kilograms and 10 to the negative 4th power kilograms. In other words, 0.1 grams for the biggest bits of dust. And the density of the dust cloud through which our planet travels is approximately 10 to the negative 6th power dust grains per cubic meter. And in interstellar space, it's only 1% as dense as that. So you're not talking about much dust at all in interstellar space. However, when you're traveling at 99% of the speed of light, you are traversing lots and lots of cubic meters of space in a very short amount of time. So this still could be very, very hazardous to your ship. There are a number of ways to deal with this. First of all, you could use high energy lasers to either incinerate or ionize the dust, incinerating it and therefore making it harmless, or ionizing it and then gobbling it up with an electromagnetic scoop into your spacecraft and converting it into fuel for your spaceship, making a hazard into an asset. Or you could have a cloud of nanomachines traveling ahead of your spacecraft doing the same thing. And that could be what we are seeing with 3i Atlas. At one time, it might have been traveling very, very fast, but now that it's reached interplanetary space within our solar system, it's had to slow down because small rocks, small asteroids, and larger clumps of dust become far more common. But even at 60 kilometers per second, impacting a small rock or other tiny object could still be damaging to the spacecraft. So the nanomachines are still traveling ahead of 3i Atlas, cleaning anything out of the way that could potentially be damaging to it. So what we are seeing is an interstellar spacecraft that decelerated once it reached the fringes of our solar system, and what we're interpreting as a cloud of dust or anti-tail traveling ahead of this object mysteriously, and very few anti-tails have been seen in all of the comets that we've observed in the solar system. We're talking a total of 9 comets out of 8,000 catalog comets. So what we are interpreting as a dust anti-tail is actually a cloud of nanomachines clearing any navigational hazards out of 3i Atlas's way. This would also explain why this cloud seemed to be active at a distance of 6 astronomical units away from the sun, when there should have been no outgassing and no anti-tail of any kind coming from 3i Atlas, and yet there apparently was. So I hope the 3i Atlas interpretation was worth the wait, guys. Thanks very much for watching. Please don't forget to like and subscribe, and also check the description for various ways to support this channel, especially on Patreon. Thanks again, and until next time, stay angry about space.